So, where's my slide presenter? Okay. So welcome. My name is Andreas Wolf, and I want to give you an insight what we can do as a machine builder with 3D printing, additive manufacturing. We started 20 years ago with this type of robots with kinematics. It's a parallel kinematic we're using for packaging application mostly. And of course, you can think of what's important if you want to drive very fast with such a kinematic. You need a light gripper, so it has to be light, less weight on these grippers. So we always start with a gripper design in our projects when it comes mostly to vision systems and when it goes to the design of the whole machine. And starting at 2003, we had only these type of materials with stereolithography parts, which were not able to bring directly into the production. So it was just for prototyping. So we started with only prototyping with the first grippers. But of course, the industry addressed us. We should pack a lot of things, and of course, we needed the grippers in a better quality. And so 2008, we started to integrate with PA12, the new materials from laser sinter machines. And we also started to build flexible structures in order to grip different types of products. So this gripper was used for all the variety of these parts from Fischer here in this project. As it went on, we also went into the food industry with these picking applications. And here, of course, there came additional challenges. We need food-approved surfaces. So we had to clean the parts and to make sure that the material is FDA approved, for example. Again, here we are using 3D printed fingers. And also the base structure of the gripper is also 3D printed. And from that encouraged, we had a lot of picker projects. We see here loading, this is for medicine parts into a thermoforming machine, triple picking with suction grippers. And we need there a very high accuracy in picking the parts to be very exact on the top of the parts. Also pharmaceutical, it's too fast. Pharmaceutical products have been handled with these fingers, but our biggest application is in the sausage industry for handling the beefies. If you look at robomotion salami, you will find in YouTube a video, you can look at it. What was the challenge here? The challenge was to be under 1 kilogram with a total gripper, because the robot can't lift more than 1 kilogram of weight to reach that speed. We are packing here 600 sausages a minute with 4 robots. You can imagine who will eat all these sausages. But it's now the 5th line we had installed here at Unilever, so quite a lot of people seem to eat the sausage. Encouraged from that, we were doing also applications abroad. So this is for a Mexican customer. Can imagine in Mexico you eat a lot of tortillas, so we had to realize that in handling tortillas. And this was a prototype we started 10 years ago. Now it's a very good customer, and we deliver these type of parts since 10 years. And this is a challenge for today, to print these parts in a way that is accurate. And what we often get from our suppliers, we don't have our own machine, is parts like this. You can think of what happened during the process by producing these two different parts. This one is unusable. Yeah, we had to throw them away. We get many excuses by our deliverers, suppliers. Yeah, so a new person was in the production, so it was taken out too fast. We had problems with the powder. So, and this is a challenge for us as a machine builder, to keep the quality constantly. We need a constant quality from you as a machine builder, and as the professor before told, we need also the processes to be repeatable, that we have a repeatable quality in our parts we get from our suppliers. It is much easier if you have, for example, a suction gripper. So these type of grippers we developed 15 years ago with kind of gripper type, because here the accuracy mustn't be in tenths of a millimeters. We can come up with a few millimeters tolerance, because the height must be not that accurate. Also the distances must be not so accurate. And from that we are quite happy with this technology. And we are delivering a lot of these type of grippers to our customers with a machine. So this is a normal production for one machine. And here you see how they are used. I hope the video starts. So this is a typical application. So after the packaging machine, the products have to be sorted in a special way on the conveyor belt, so that the next robots can pack them into the carton. Also an interesting thing is to combine traditional milling technology with 3D printed parts. So this is nearly 500 millimeters long gripper, which has a spreading unit inside. So if the product comes in a certain distance here in the mold, we have to transfer it into the packaging machine with another distance. So during the handling operation, the gripper spreads the product and place it into the wrapping machine. So these are nearly 1,000 of these chocolate pieces per minute we are loading into the packaging machine. And again, here we are fighting with tolerances, with the process to keep it stable, because the distances has to be really accurate between the different bearings here. So this is not really easy to produce. Another gripper type or tool type we used here, the customers needed a very light structure. We had to grip 25 products at once and had to shrink them in X and Y direction in order to come into a carton. And here we designed also the kinematics for shrinking the products inside the 3D printed structure. So here you see just a structure, and here is all built in the kinematics to squeeze the products together and to spread again. And so we were able to build this gripper in a very light way. Yeah? So it was not too heavy for the robot which should lift it. But at the end of the project, the customer came up and said, we delivered the machine, and the customer said, how many cycles will this do? When do I need a spare part of this? Can you imagine? We have in this production, this is a 24/7 production, we have 5 million cycles a year for this spreading operation. So we should reach 5 million cycles. And when we were fighting hard in reproducing 5 million cycles to test it, and in the first run we had 300,000 cycles to reach. Were reached by our testings. But afterwards we had 18 million. So we improved the design to reduce the forces inside the connectors. And this was, so we were lucky to reach the 5 million cycle goal. So these are the challenges the machine builders are fighting with this type of material, and we try to keep in touch with others, with other machine builders and also suppliers to talk what can be improved. And therefore we are in the VDMA, which is our organization, the machine builder organization, and we are in a contact with other machine builders to improve this technology. And from that we came 10 years ago into the plastics industry, and there we used also the same 3D printing technology. These are the customer products. This was the old production way, how they produced the products 10 years ago. And they had a lot of damages to their products during the process of feeding. So we changed the production process from this traditional assembly process to a robot assembly process. And therefore we printed all the fingers and all the handling devices with 3D printing. So this was the old machine. And this is now the new machine. So we were connecting 3 injection molding machines. So here you see 3 injection molding machines, and they work together on one assembly spot. Yeah. So here the grippers take out the products out of the injection molding machine and deliver it to the assembly process. In this machine, in beginning, there were over 300 3D printed parts, different places. But due to the very high accuracy we need here, we had to reduce the 3D printed parts. Yeah? So that's why we are looking for more accuracy in the 3D printing processes. Yeah. So, and these machines are running 24/7 Saturday. So here you see the 3D printed grippers for the parts, and here the final assembly process. And then it goes to the next assembly process. So, and then this is the last assembly process which is done, and then it is brought to 100% control. So every part which is produced is 100% checked by a vision system. So these are high productive machines. But without 3D printing, we couldn't build these type of machines. Especially in prototyping, in the beginning of a project, we needed 3D printing to build these type of production machines. So that's why I'm asking, as a machine builder, if somebody feels good to help us with such problems, we are looking for partners to do more accuracy in additive manufacturing in order to work better in the machine building. So these are the products which are produced on this machine. Okay, any questions?